Um, and the recordings will be saved in the team space. If you're here at the meeting and you're not in the WebEx team space and you want to be part of future meetings or invited to future meetings, reach out to me. It's D Creamer, DCreemer. You can see my name in the WebEx, but reach out to me and I can add you, or reach out to whoever shared this link with you and have them reach out to me, and I'll add you to the team space. The team space is how I manage the membership of the group, so that's how I know who to send the invite out to every month. And if you like the content and want to share it with others, feel free to reach out and suggest I invite others as well. We've got a great meeting today. So Tony Peters and Julian Mcroy, they used to be peers of mine, but they've now gone on to cooler and more exciting things with evolving solutions. And but they're both wizards with ACI and know and can do all kinds of great stuff, and they're here to share their knowledge with you. I'm trying to think if there's any other outstanding business before we hand off. And the last thing I will say is, if you enjoy the presentation today, throw something in the chat at the end. Let us know that you enjoyed it. Let us know, how to keep making these meetings good and relevant for you. If it's working well, let us know. If it's not working, let us know how to fix it. But also, if you like Tony and Julian's presentation, which I'm sure you will, look for their presentation next month in the automation users group, because they're going to be back to talk to us again over there. And with that, I'll hand it off. Tony, Julian, whichever one of you guys want to lead off, I'll hand it off to you.
So I'll lead off. Appreciate that, Davis, and good afternoon, everybody. A lot of familiar faces on the WebEx and on the invite that I've worked with through the years. But as Davis mentioned, I worked for Cisco for 11 years and just recently transitioned into the VAR space, in particular, kind of a smaller regional VAR of like the central United States. So same patch that I was covering, but much smaller team and more focused. And obviously, one of the things that we're very focused on is ACI. Both Julian and myself, I am the network practice director of our network security practice, and Julian's a senior solutions architect for us. We've both been with ACI ever since its inception. So been through the good, bad, and the ugly with the platform, and have lots of experience to share on it. And so today, this is a topic near and dear to my heart, and one of the things that as a architect at Cisco, I would sell ACI, and one of the key selling points I think that a lot of you probably bought it for was security, and it was a good selling point. But then when it got to the practicality of putting it in or installing it, it seems like the integrators out there or the technology itself, it just wasn't ready, and there wasn't capabilities there to make it more easier to consume and use the security functionality of ACI. And so essentially what this talk was about is like just trying to get more value out of your investment, right? It's nothing that we're selling or anything like that. I just, I've done so many health checks the last 6 months to a year where I would log into a customer's fabric and go through it with them. And then in every one of them, they were getting very little value from a security aspect on ACI. Now, there's lots of other aspects, of value there that they were getting, but the common theme was they were all lacking on security. So that is a problem, right? When one of the key value things of the platform is something and the customers aren't getting it. And so again, that's kind of what we're set out to do today. And as you guys all know, the need for segmentation is only rising. All these ransomware attacks and whatnot, and we've seen it with customers now that we're speaking with. Security and segmentation is very, very real and top of mind, and people are actually starting to break it down into practical chunks rather than trying to boil the ocean. And that leads to really the last point. Like we're not here to say ACI or any other platform is the one all be all for everything. It's more of a defense in depth strategy. And what we again wanted to share today was just some ideas of like some real value we feel that you can get out of the platform from a security aspect, and show different topologies and things like that. So again, that's kind of the problem statement out there that we're trying to hopefully shed light on and give you ideas on how to turn that into something better than a problem. So the agenda, really, Julian's going to kind of kick it off. And for some of you out there, I'm sure we have a wide variety of users on the call and part of the user group. Some of it might be one-on-one, but then these concepts are all going to build into the 201 and 301 that we'll be showing by the end of the talk. And so we're really going to talk about the transition from network centric. What does like an optimized network centric look like? Because as everyone on this call, I mean, I'm sure you guys are all managing different fabrics. I would be willing to bet that no two are alike. And so everybody's doing things differently. And so we're going to go through some of that in whiteboard form and talk through that, and then as well as transition methods. And that will get more into the use cases. And this is kind of where, we'll show some demos and discussion points that we can have with everybody on common things that we're seeing on real segmentation projects in users' data centers. And the common themes are, which we'll show, is kind of denying user access to the crown jewels. And the crown jewels could be, databases. It could be something within the data center that, no user should be able to access. But yet, the other things within the data center need to do that. Could be a whole application as well. And so how do we start using the platform for doing some simpler things like that, rather than trying to boil the ocean and do micro-segmentation everywhere and things like that? And then just kind of working the way down the line. Like one huge topic in today's world is securing backup networks, allowing backup networks to be able to speak and talk to what they need to talk to, but not allowing your users to be able to access your backup networks. I mean, if you get hit with ransomware, that's your one saving grace to be able to go back and restore the backup. And you better be protecting these networks and keeping them secure and keeping track of access in and out of those networks. And then the same with like, how do we start offering shared services and securing management networks? And so that's the agenda today that we're going to go through. Only one slide I'll share with you today, and that's the beauty of being on this side of the fence rather than the vendor side. No, we're just gonna jump into whiteboards and get to work.
Let's see if there's a, oops. All right, we're just gonna make do with this. So, to Tony's point, right? I mean, a lot of customers, right? We both have kind of been in this game for many years, since the early days of ACI, and we watched it. I remember the first time I sat down with ACI and deployed a layer 3 out, and I got very confused halfway through the process, right? Like, where am I and what exactly am I trying to achieve? Going through this workflow. So ACI has, since the very beginning, we've been talking about data normalization, first hop localization, segmentation, application-centric security. And a lot of those things, probably were a little bit pipe dreams, and the way that many customers chose to adopt ACI was much more network-centric. So kind of halfway through that life cycle, we started talking about network-centric versus application-centric, right? That we came up with those semantics for a reason, because customers were in large part adopting ACI in very network-centric ways. So it was actually quite a blast to go through that process of watching ACI evolve from this thing that was very difficult for me to wrap my head around in the early days to kind of where it's at today, right? I mean, there's still a lot of meaningful things that I think exist on the roadmap. There's always room for improvement, but we're in a much different space and time than certainly what we were 2014, 2015, right? And our ability to satisfy network requirements for multiple data centers, active DR, active, multi-data center, multi-cloud, normalizing policy across clouds, right? We're just in a different place, certainly with ACI. So acknowledging there's a lot of people on the call today. I don't know where, it's not like we're in the same conference room. So I'd ask, like, show of hands, how many folks have ACI deployed in production? How many folks are like super, have vast experience with ACI and are consider themselves to be experts? Who's beginner? I'd love to kind of get a feel for the audience here, but that's obviously pretty difficult to do in this context. So I'm going to kind of start from the beginning, like Tony said. We're going to discuss a few things that are kind of one-on-one, and we'll keep building and work our way towards the more interesting stuff that's possible with ACI. Tony, does the resolution look okay? Does the screen look fine? The screen size?
It's fine. It's just, we don't see just a page at a time, but it's fine.
I know. I'm sure there's a way to do that. Let's see.
Enter full screen.
Yeah, I was going to try that, but It's still not a page at a time.
You're fine. Just go with it.
Yeah, I'm just going to go with it, man. I've wasted enough time. Okay, so anyways, in order to kind of have this conversation, we have to start kind of, with the basic building blocks here. And so let's see if I can get this. There we go. Some of the basic building blocks inside of ACI, right? And you have to understand the object model in order to start dissecting and doing, service graphs that are applied on contract subjects and things. I mean, you kind of have to understand the fundamental blocks, and we're going to kind of work our way through that. So really quickly, and I promise I'm only going to spend about 30 seconds to a minute talking about the object model and talking about provider-consumer relationships, but it's important to kind of level set in that regard. So obviously in ACI, the object model requires a tenant object in order for you to have communication inside of the, and by the way, let me highlight this too. So this is right off the CCO. This is, a structure that has existed, kind of a visual representation of the object model for many years. And I just grabbed this right off of CCO. So, or off of Cisco's website. So solid lines indicate relationships where the application profile, as you guys know, is a child object of a tenant. Endpoint group is a child object of an application profile. Dotted lines illustrate relationships on EPG. Will not work unless it's connected to a bridge domain. So bridge domains do not function unless they're connected to a VRF, even at layer 2, so on and so forth, right? So those are the associations as opposed to child objects. And then of course we have our relationships, one to many and many to many, and those are kind of illustrated here. So the stuff that I'll call out here really quick, right? It's important to understand, obviously ACI offers a group-based policy model when I start building security. By default, and certainly where we've been for 7 years now, is the endpoint group is the least common denominator in the data center. No one says what VLAN is that server on, it's what endpoint group is that server on. So the EPG certainly is that least common denominator, and it's the object that represents the group-based policy model of ACI. There's also this notion of an external EPG, which of course we use to identify resources that are outside of the network. So these two sit beneath the application profile and beneath the outside network respectively. So these are certainly important building blocks as it pertains to the security constructs that we're going to be talking about later on today too. So I'm not going to talk about each one of these. Bridge domains, is certainly is a construct that allows us to preserve layer 2 flooding semantics and defines the perimeter of that flooding domain across a distributed fabric. IP subnets, are an object that are attached to a bridge domain. The ones that really matter in this context are these guys over here. The contract filter and subject, or the trio of these 3 objects help us build security policies. So the subject sits beneath the contract, and we can have multiple subjects sitting beneath the contract, each with different filters, and those filters will call out ports and protocols. So the combination of those 3 and their associations to endpoint groups is how we build policy. So like I said, 30 seconds to a minute. We got to at least kind of talk about these pieces before we start talking about service graphs and policy-based redirect, right? Contract relationships. It's also important to understand the provider-consumer relationship across endpoint groups. So what I have depicted here is a web tier, a web EPG that has a web server. It's serving up TCP 88443. My intent in this particular example is I have VDI, and I want VDI, I've got a virtual machine here that needs to be able to connect to the web server. So the way that I'm going to do that is provide, wherever the service is being provided, that's where you provide the contract from that particular EPG. I mean, you'd be surprised, this is a fundamental basic thing, and most of you on the call probably like, yeah, this is table stakes, right? But this is a very confusing thing that confuses a lot of people until you wrap your head around it. So you provide the service from this, provide the contract from the EPG where that service is being provided, and you consume it on the other side. And this is a many-to-many relationship. So I can have many other consumer EPGs, and for that matter, many other provider EPGs, all providing and consuming that same contract. The directionality of this relationship, provide and consume, goes opposite the direction of traffic flow. My intention is for VM1 to be able to talk to the web server. And so the directionality of my provider consume is opposite the direction of the traffic is actually flowing. Again, table stakes, right? So let's kind of put this all together. We've got, a fundamental building block. I need to have a VRF in order for there to be communication on inside ACI. I have to have bridge domains, and assuming layer 3, then of course we'll want IP subnets associated to those BDs. The bridge domain doesn't function unless it's attached to a VRF. I need to have endpoint groups. My endpoint groups are what we're using to attach endpoints, and historically has represented the group in the group-based policy model. So I attach endpoints. In this example, I've got VM1 attached to EPG1. Data plane normalization, we've talked about that for years. We don't care if it's virtual, we don't care if it's physical, I don't care if it's Kubernetes or if it's a bare metal server or a VM running in Hyper-V or VMware. It doesn't really matter, right? We can normalize communication across the fabric so that VLANs become simply an access encapsulation method and a way for me to identify endpoints and how they map into endpoint groups, right? So VLAN 100 on the left side of the data center can be the same entity as VLAN 200 on the right side of the data center, gets normalized on the endpoint group. And that's what allows us to connect all these different types of endpoints and have them associate to the same EPG. So those EPGs now, of course, associated back to bridge domains. So EPGs don't function unless they're associated to a bridge domain. And then we need a contract. So fundamentally in ACI, assuming you don't have VERF unenforced turned on, which we'll talk about here in a minute, then EPG1 and EPG2 cannot talk by default, zero trust, right? I need to have some type of policy that's going to allow them to communicate. So in this particular example, I'll create a contract and I'll call it allow Active Directory or whatever this service is that's needed. In this case, I'm providing that service from EPG1 and I'm consuming it across these other 3 endpoint groups. So the idea is that any one of these endpoints can now access that particular service. Now, there's definitely some ways to optimize this, and we're in this next page, we're gonna kind of get into some more realistic, real world examples on how this stuff is deployed. But there's some options in how to tweak this. This is just fundamentally, how do I make sure that I allow communication? I need contracts, unless there's methods for me to not need a contract, which that certainly is the case. But I need contracts in order to allow that communication, and the direction of traffic is opposite the directionality of the provider-consumer relationship. The one thing the contract allows me to do as well is to define a service graph. So that service graph is defined as part of the contract or in a subject under the contract. And that allows me to stitch traffic toward the firewall. So we're going to talk about service graphs and policy-based redirect in one of the upcoming pages here. So before I proceed, any questions there? I mean, obviously, again, this was just a quick 3, 4, 5 minute review just to kind of talk about where have we gotten up into this point. We'll pivot next into, okay, how are customers deploying this? Again, I'd love to do a show and kind of see, as we talk about these different examples, what do you guys have in your networks? But in either case, any questions about this fundamental stuff before we kind of pivot to next page? Okay. So common deployment examples, right? I mean, obviously there's one of the challenges that I certainly have always had with ACI is there's so many different ways to achieve things, whether we're talking about fabric access policies or whether we're talking about building, provider consumer relationship across contracts and EPGs. There's different ways to skin, to achieve the same goal. So one of the things that certainly has been supported since the very early days was VERF unenforced. VERF unenforced mode, basically, it's very binary in nature, right? So it means I can go to the VERF and say, let me turn off enforcement altogether. And by doing so, EPG1, EPG 101 and 102 are both on this particular VRF. And now they can talk without any contracts. Well, this works. This works perfectly fine. That's your end goal. The problem with this, and the reason I put a circle with a cross around it, is because you shouldn't do it, right? Realistically, I mean, there's quite a few things that I'll probably say, well, I wouldn't do this if it were me. But the real problem with this is that if you want to pivot on that same VRF towards having policy, since it's binary, when you go turn on VERF enforcement, then your contracts better be set up correctly. Otherwise, you're going to cause service disruption. So this doesn't really provide a seamless transition strategy to start doing more sophisticated security things. This opens up the floodgates, and the intent, the idea really, if you're doing this model, is that you're never going to lock anything down. And there's better ways to do this, right? There's better ways to achieve that same level of unenforcement early on and do more restrictive security as you proceed. At one to operationalize ACI and want to do more sophisticated things, there's models that we can use here that offer greater degree of flexibility. To that end, one example, much more common. VZN really is all construct, and it provides to share something from the VERF directly, meaning any endpoint group that is associated to a bridge domain that is attached to this VERF can either provide or consume this particular service, depending on the directionality of my contracts. Right. So in this particular example, I've got an EPG that is serving DNS and NTP, right? It's providing that service to the network. So my endpoints that are in here are probably going to be DNS servers, NTP servers, and whatever other network services we choose to lump in here. So it's going to be providing that contract. And in this case, to simplify, because I know everyone's going to need DNS, likely most will need NTP, perhaps DHCP, Active Directory, list other things here that might be needed. I can simply provide that contract to the VRF directly, consume it from the VRF. So I'm basically going to provide the contract on the EPG, and then I go to the VRF configuration and I consume that at the VRF. And now any EPG that indirectly is associated to that VRF by way of its associated bridge domain is now going to be able to consume DNS and NTP off of that. So this is a way to really preserve TCAM, to not use nearly as much TCAM, to simplify the configuration. And this is just one illustration. There's a lot of different ways that you can use VZN, and you can use it to achieve kind of something similar to VRF unenforced, whether or not that makes sense. But doing it on more a per use case basis is what I generally have recommended over the years, and what I've seen a lot of customers do. Use it where it makes sense. Don't try to use this universally. Another and perhaps more common model, and I would expect the show of hands to be, a pretty large percentage of the audience, full mesh, right? And what I mean by full mesh is that all of my EPGs, and I've got 4 depicted here just because of space considerations. Space, this is obviously going to be 200, 400, 50, whatever that number is of EPGs that mapped into this environment from your previous architecture. If you had Nexus 7K with back-to-back VPC or Fabric Path and pivoted into ACI, then you more than likely did a very network-centric transition into ACI. You set up your layer 2, layer 3 integration points, and you provided that onboarding to move endpoints in, and you ended up with 200 EPGs. And to simplify things, because most customers, when they're doing that transition, they don't know what are all the ports and protocols required across all of the different endpoints that exist inside of that fabric to go down and lay down policies on top. So what most have chosen to do is to use this full mesh design. I'm going to create one contract, and I'm going to provide and consume that contract universally across all EPGs. And I have my external EPG doing the same thing. So the idea with this is that endpoints sitting out here outside of the fabric, outside of the data center, would be able to come in and be able to access any one of the EPGs that exist inside of the data center. If I'm sitting inside the data center and I'm on EPG 201 and I need to get to EPG 202, no problem. I'm providing and consuming the same contract universally. Therefore, I have unfettered access, no restrictions. So this, in essence, achieves the same things VRF unenforced. It certainly uses more policy TCAM, but it offers flexibility so that when I need to do more specific and granular things, for example, I may have multiple full mesh environments. I may have, let's color code this. I might have a green environment and a red environment. In the green environment, I'm going to do full mesh, meaning I have a green contract, and it's provided and consumed across all of the green EPGs. And I have a red contract that's providing consumed across the red EPGs. I can still provide that demarcation so that red can't talk to green, but within those environments, they can talk to each other. So that's another kind of a scenario with full mesh that makes sense, right? This is a model that works, and it offers that flexibility so that when you want to do more sophisticated things, I want to start peeling off endpoints out of EPGs, putting them into different EPGs, or peeling off existing EPGs and instead of consuming the full mesh model, I want to do more restrictive contracts. This offers that flexibility so you can actually do that. Now, there's still additional alternatives here, so I'm going to keep scrolling, right? We've got preferred groups. So preferred groups is, again, kind of comes from that whole network-centric model where a VLAN equals an EPG equals a bridge, EPG/bridge domain/IP subnet that most customers have and how they got into ACI. I've worked with quite a few customers over the years that chose to do preferred groups because it was that easy button that said, you know what, for all of the things that I'm pivoting in this example, I've got 3 EPGs and 1 external EPG, I can put them into the preferred group so they can talk to each other without any restrictions. And of course, I have the VRF drawn out here again because this is a VRF level configuration, right? This is also binary in nature. It's either preferred or it's not. So you go to an individual EPG and you say, you're in the preferred group. Or if I don't put it in the preferred group, then the assumption is it needs more specific controls as to what traffic is going to be allowed for those EPGs that are not in the preferred group. So these things can coexist as we have depicted here, right? And one thing I'll call out too, there's different approaches here, right? And I've worked with customers that have used different approaches based on guidance, from conversations with me, conversations with advanced services, conversations with other VARs, there's multiple ways to achieve this, but one of the caveats on an external EPG is that you can't put the quad 0. So if you go, of course, this subnet definition under the external EPG has much more to do by default with security than it does with routing. So if I say quad 0/0, that prefix, that default, if you will, is not something that's allowed to be part of the external EPG. So you can do split routes. I can do a 0/1 and 128/1, so that I can still achieve the exact same goal and still put the external EPG into the preferred group. This is something that works. There's other ways to go about achieving this. Now, in this example, I've got EPG 203 and 204. And those two EPGs, I don't want them to be in the preferred group. That's the whole goal of this, is I can support the brownfield, all of my existing stuff leveraging preferred groups. And if there's stuff that I'm bringing in that I know day one I want to be able to provide security for, or certainly day 2, day 30, as I'm standing up new applications and I have an opportunity to build more app-specific policy, now I can do that, and those two can coexist. I can have my preferred group stuff still running without security controls, and then I can instrument, in this particular example, I've got EPG 203 and 204, and they're providing a web service. And they're providing it to that same external EPG that references the external world. But in this particular case, that web contract has a service graph assigned that sends traffic via policy-based redirect, in theory, toward the firewall. Right? I can also simultaneously support the external reachability requirements of these two EPGs, because they need to get outbound for going to do software patches or whatever, right? If they need external connectivity outside of the fabric, I can have a contract relationship between the external EPG here that says, here, I'll allow you to gain access outside the network as well. So there's ways to use these types of features to keep things simple. I'm a big fan, and learned in the service years ago, keep it simple, stupid, right? I'm a big fan of keeping things simple, keeping things scalable, but using the features where they make sense if they add value. And some of the, preferred groups is certainly one of those features that has worked and has added value and made things simple to open the floodgates where you intend to, and simultaneously have more restrictive policies where you need to. So another feature here that we can use to optimize, this is really an optimization feature. I mean, it's not going to have any impact on policy TCAM, but it certainly will have an impact from an administrative perspective. How do you manage policy inside of an ACI fabric? So if you've got like a baseline configuration where, let's say you've got, I call this master EPG. This is how it actually is referenced as part of this feature. But basically, I know that every single EPG in this particular environment, or at least some aggregate of EPGs, anything more than one, is going to be needing the same policy. I can use contract inheritance to simplify how that policy gets laid down. So I can build the policy once. And when I build the policy, I know everyone needs to provide management, which may be, and these are just for illustration purposes, SSH, RDP, HTTPS, or whatever is the case. I can be specific as to what the source EPG can be in terms of getting, external or internal, to be able to gain access into this. But I want to filter this down to specific ports and protocols. I know that each one of my EPGs will need next services. And I know that each one of my EPGs will need to be able to get outbound for, software patches and those types of things, or whatever they need to reach outside the fabric for. I can create a kind of normalized template that says, okay, here's all of my base config. Everyone needs this. And by the way, I'll let you outside, but you have to go through a service graph that sends traffic to a firewall for that external reachability. And this is going to be everyone's config. I need that to consistently be the config for all of the EPGs in this particular environment. You create this policy once. When you need to update this policy, you come back and update it here, and it's going to apply universally wherever this inherited contract is being consumed. So the way that works is I go and I create my master, create all of the relationships that I need, and then I associate it as a contract master to all of the EPGs where that same policy needs to be applied. So in this example, I still have my external EPG, I've got a web app EPG, and I've got a database EPG for a specific application that has all of the contract relationships that make sense, so that I can allow traffic from the outside world into the web/app tier, and from the web app tier down in the database. And all of that can be custom and unique for this particular application. But in addition to this policy, my expectation is that all of this stuff, and this is really hard to do without an Apple Pencil. I'm using 2 fingers on a trackpad and it still works. But anyways, I want to make sure that all of that stuff gets applied as well to these 3 EPGs in this particular example. So contract inheritance is a great way to kind of simplify how you're managing reusable stuff. So you're not recreating the contracts over and over again, or recreating the consumption model of those contracts over and over again. Okay. And I just realized something, but that's okay. We're going to keep cruising. So endpoint security groups is something, absolutely point out to you, right? This is a relatively new feature. I am missing a couple slides, so I'm going to probably pause in a minute here and see if I can pull up the latest. My apologies for the complications here from a technology perspective and not being able to get my iPad shared here. I threw a pretty big curveball into my plan, but I'm going to spend a minute here to see if I can pull up the rest of this presentation. Anyways, endpoint security groups is also something definitely worth pointing out. This is a newer feature. This came out as of 5.x, right? It came out in a 5.x release, 5.0. It may have been 5.0 originally, but certainly in a 5.0 release. 5.1 release obviously supports it as well. And if it were me, I'd be really thinking about this with 5.2 because, obviously, you're only going to adopt a short-lived release if there's some killer feature that you absolutely need, but every customer I've ever worked with, even still today, is on 3.2 or 4.2, right? They're on the long-lived releases, and everyone's getting on 4.2 at this point, if they're not already there and haven't been there for quite a while. 5.2 is right on the horizon. Davis, you probably have some pretty good perspective on when that's supposed to come out at this point, if it's not available already. But that's where I would be thinking about endpoint security groups as a significant feature that is going to add a different layer of abstraction to be able to put security down on endpoints, right? So if we talk about the layer of abstraction that already exists between the bridge domain and the endpoint group, providing two different namespaces, right? The bridge domain offers a namespace that defines the IP subnet, whereas the endpoint group offers a namespace that provides the identity, right? That fundamentally has been the case since ACI 1.x, right? The ability, and what I mean by that is the ability to have multiple endpoint groups attached to the same bridge domain is something that has, we consider this table stakes certainly at this point, but this type of capability was really difficult, extremely difficult to do and manage at scale in traditional networks, right? How could I have endpoints in the same IP subnet attached to the same switch fabric, but provide east-west security? The only way to achieve that historically was to use private VLANs. Good luck managing that, certainly at scale, right? So to have this fundamentally part of the design of the network, so that my group-based policy sits at a different plane of abstraction than my IP subnet, offers up some pretty incredible things. And I have an example of that we'll talk through in a bit here. But it also has limitations because I can't, the one-to-one relationship between EPG and a bridge domain in that direction, right? Obviously, bridge domains can contain many EPGs, but any given EPG can only be attached to one bridge domain. And that is the caveat. That's the limit. What if I wanted to have one policy that mapped to EPG1, but also have it mapped to EPG2 and EPG3? I'm going to have to duplicate policy in order to achieve that. I'm going to have to treat these as separate entities, each with their own policy. That's fundamental to an endpoint group. If I want to be able to create a completely separate plane of abstraction where I can write policy independent of all of the network namespaces, all of the network constructs. So bridge domains, VERFs, EPGs, those things don't matter. They certainly still matter in the grand scheme of things, but they don't matter in the context of defining policies for endpoint security groups. That's what ESGs do, right? They provide that completely separate namespace where I can grab endpoints out of multiple IP subnets, and I can define those endpoints today as a 5.1 based on IP subnet. So the IP subnet is the single selector available today. With 5.2, EPG, as well as, I don't know exactly what list we're going to be getting specifically with 5.2, but the things that are on the roadmap are basically many of the same attributes that we can do for EPG associations. So VM attributes, vSphere tags, MAC address, certainly still IP address, EPG, right? These are going to be the properties that will be available. So you can say, I'm going to define my ESG membership based on the EPGs that exist today, and I can write the policy once. So this is going to help conserve TCAM. This is going to make policy configuration a lot simpler and more straightforward. There's caveats, as with all things. There's caveats. This works, with routed traffic, So if you're looking to do granular east-west segmentation, and you'll notice I haven't said anything about micro-segmentation, I haven't said anything about contract inheritance, I haven't said, or excuse me, about intra EPG contracts. I haven't said anything about inter EPG isolation, right? Those specific features I've kind of left off because I usually don't do those because those require private VLANs and proxy ARP. And, you know, if that's something you're trying to achieve and you're okay with that, then that's perfectly fine. I prefer to keep things simple and to not have those types of dependencies. So if you're trying to do east-west, more granular east-west, there's definitely ways that these can kind of coexist with policies that where you have granular east-west from a layer 2 perspective. Or for that matter, I may be able to start taking endpoints and group them into EPGs in a different way so that they can then map into endpoint security groups. I'm still writing the policy once based on an aggregate of EPGs. So I'm still conserving policy TCAM. I'm still writing the policy once. And there's an additional optimization that also sounds extremely interesting. We'll see kind of where this goes is inter-verf route leaking, which always has been like this scientific exercise of exporting contracts across tenants and consuming a contract interface, and magically route leaking happens on the back end. As part of this new ESG support, inter-verf route leaking is vastly simplified as well, right? So it's not a science project anymore. It's an intuitive user experience to define which subnets need to inject across verfs. So this ESG thing, like I said, it's not something that I personally would do today, but it's something I would definitely keep an eye on as it matures and as more features become available with this in 5.2 to be able to provide this separate layer of abstraction for defining policies on how endpoints should be able to communicate inside the data center. Some things to point out, right? Support for preferred groups is available today. So I can take an ESG and have it in the same preferred group as my EPGs and allow communication that way. VZNE is supported today, right? So I can have ESGs, that are providing consuming contracts that are associated to the verf. That's fully supported today, as well as using contracts that are either just defining specific ports and protocols, or for that matter, have a service graph. So I can have multiple endpoints in ESG. In this particular example, I'm picking out these IP subnets, putting them in ESG1. I'm picking out 10.1.103 off of BD3, and I'm putting it on ESG2. And then I'm providing and consuming this contract that says, in order to get here, you've got to go through this firewall, also fully supported today. So this is something to keep on the radar as you consider, how do I apply more secure policies inside of ACI? Do I need a different plane of abstraction that frees me or decouples my policy from the networking space completely? That's what endpoint security groups will do. Okay, so I need to skip some of this because some of my slides didn't come across correctly. But before I do that, I'm going to jump into this one last example here. So I called this one app-centric-ish customer example. This was an actual customer that I worked with, and this was large scale. This is a big healthcare provider, right? And they needed the ability to conserve IP address space, use the same IP address space, but still provide east-west isolation across applications. This was a specific environment where they had developers coming in, and those developers needed to be able to have their own sandbox. So this is not so much about writing application-centric policy. You know, if you ask even folks within Cisco, I mean, I've never been a big fan of the whole network-centric, application-centric terminology. I think there's more meaningful conversations that you can have about, are you doing things that are adding value? But, certainly it's still important to understand what you're trying to do from a policy perspective. So is this application-centric simply because I have multiple EPGs associated to the same bridge domain? Maybe. I think probably there's more to the story for what application-centric, at least what it means to me, in order to be able to do that. But in either case, this is certainly more sophisticated config, because and yet simple at the same time, right? What they intended to do was to be able to have the same bridge domain, have multiple EPGs attached to that bridge domain, provide east-west isolation such that app 1, app 2, app 3, in this particular example, all associated to their individual web tiers, there's no east-west communication allowed. And yet I can allow for external reachability. So there was dedicated contracts across each one of these EPGs, and those EPGs were all being consumed by the external EPG, which in this particular case was connected to a pair of firewalls. Just happened to be a pair of Palo Alto firewalls where they were doing north-south security. In this particular case, it was the firewalls were the peer from the layer 3 out. you can certainly insert this via a service graph and be more descriptive or prescriptive, I should say, about which traffic needs to go to the firewall and what doesn't. But in this particular example, they had all traffic north-south coming through the firewall into the fabric. And by having dedicated contracts in front of each one of those EPGs on a shared bridge domain, I was able to provide, not only the traffic flows into application tiers that were required, but most importantly, provide the necessary segmentation such that there was to minimize a threat vector from an east-west perspective, right? As well as taking that same model and applying it to the database. This is, of course, a very simplified view on what was built here, but same logic, right? Take that same logic. I want my database tier or my other application tiers to be kind of a stamped out model where I've tested this, I've validated, I know it works. And when I have app 4 that needs to come online here, right? Whether, and how it maps into the application tier, whether it's using a shared database or if it has its own dedicated database. We went through extensive testing here relative to how to automate this, right? Based on they had a homegrown automation tool that they were building to do infrastructure as code. And their mantra was, no one logs into the GUI to build configurations. If you're ever building a config, you do it through this automation tool. So this was all kind of stamped out and modeled to meet their specific business requirements. And when a new tenant needed to be onboarded, then you simply stand up another application profile associated with the same bridge domain and with dedicated contracts, and all of the stuff from an ACI connectivity perspective gave them that instant isolation from an east-west perspective and reachability from a north-south perspective with firewalls in place to provide north-south security. So this was a model that worked extremely well for this particular customer. All right, I'm going to pause for a minute. If you guys can bear with me, I'm going to see if I can get this to pull the latest version. And if I can't, then Tony, we're going to have to pivot towards the next point where we jump into ACI.
All right, we should probably do that pretty soon anyway.
Yep. While I'm looking here, any questions, I guess, about the stuff that we kind of talked through there? I guess to kind of summarize, there's a lot of different features in ACI. There's a lot of different ways to achieve kind of the same goal, whether you're wanting to use preferred groups, VZNE, contract inheritance. What I intended to kind of pivot to talk about service graphs, policy-based redirects, symmetric PBR, and how those components are kind of instrumented in ACI and how it simplifies so that you don't have to do VLAN stitching and VRF stitching anymore, but actually, where policy is necessary, where ACI is not, my view on this has always been ACI there's no one tool that you can buy that gives you security, right? It should be a defense in depth strategy. So ACI certainly can serve as one of the tools in the toolbox to provide, in security. If you want to secure the infrastructure, lock down the ESX hypervisor, we know how to do that, right? It's very simple to be able to identify the ports and protocols required there. If you want to be able to use network virtualization to provide sandboxes from a layer 3 perspective, use VRFs all day, right? If you want to use application profiles and provide multi-tenancy in that regard, whether it's shared network resources or not, but being able to provide east-west security, like some of the examples that I just walked through, those things were all possible. But you also have to look at security at other layers in the workload. Stateful firewalls are also still required. So ACI is not the one tool that's going to give you that end-to-end security. It's a matter of looking at using the features that make sense, where you're going to provide the stability, the scalability, and the segmentation kind of simultaneously. Give all of those things, right? And use service graphs to steer traffic to firewalls where it makes sense. Use ACI to provide security where it makes sense. That's kind of always been my stance. So,
yeah. Julian, should I just? I'll just go ahead and share and go from there, and we can talk through that as I go because that's in.
Yep. Yeah, go for it.
That's in the example.
Chances are I'm not going to get this thing synchronized, so go ahead and take it.
And I think, what Julian, in my experience too, is when you start getting into, security conversations and redesigns and, is the firewall the gateway? What's the gateway? It's so much simpler if you can try to make the network the gateway and then just provide access that's necessary. And I know that you guys out there probably have dealt with this with, hosts with multiple NICs connecting to different networks and doing host routing, having to worry about, those sorts of things. In my opinion, it's so much better if we can make the network the gateway and then make the network do interesting things. And for those of you that are highly segmented and doing cross-tenant things and different things like that, that obviously makes a lot of sense too, from that perspective. But basically, in the demo here that I'm going to do just really quick is just kind of showing some segmentation use cases, and then like using some of the concepts that Julian just went through to show you. And so this is the, at this point in my ACI tenure, like I hate this concept now, but everyone has it, and so many people have one production tenant with one app profile called Network Centric, and has anywhere from 30 to 200 plans in that, or EPGs in that have been statically mapped in there. For the good, bad, or ugly, that's where we're at. And so how do we go from that sort of environment to introduce some more security? That was like the main crux of the conversation today. And what you're seeing here is kind of this deployed in a way where Julian mentioned where preferred groups are used. And so I don't see that one permit any contract and everything connected to that. I'm just doing preferred group here on the endpoints as well as on the layer 3 out, as far as just, being able to just have one layer external EPG, and then just signifying on that default external EPG just the .1s that are out there. Therefore, anything north and south is being qualified and put into this. And as you see here, I'm putting this external EPG into the preferred group. So by default now, anything north and south is going in, anything east to west, as long as it's in the preferred group, can talk north and south as well as east to west. And that is, a decent way to deploy network centric, where you're just getting into ACI, you don't know what needs to be turned on, what doesn't need to be turned on. Now let's start doing some more interesting things with the fabric, and as far as like access control. And like I mentioned, like a lot of people, a lot of CISOs even that I've spoken with, one of the main things is like we've got to start securing our databases, whether it's SQL, whether it's Oracle, whether it's Mongo, what have you, right? How do I get from a network centric into like segmenting certain things? And I labeled this one network centric secure DB. And we're not going to go through all the methodologies of how to map an endpoint down into this environment, and so that can either be a regular EPG or an ESG, like Julian mentioned. But in this case, I only have one endpoint group that I'm doing, and so I want to take databases that are in an EPG here, and I want to move them down into this EPG. And so the process of how you do that is either static or dynamic, of how you do that. But as far as a policy goes, this is very common of what we see of people like wanting to use ACI for segmentation. It's been actually quite interesting to me. A couple that we've talked with have been like, they're not huge shops, but they're like, we're still going to just keep the deep packet inspection to the perimeter of the network, and we want ACI just to do the segmentation aspect. And that's one aspect of ACI. Yeah, I can do the segmentation, but the problem is when you need deep packet inspection, when you need to do threat and vulnerability and different things like that of the traffic going into and out of these segments, ACI does not do that, right? And so how do we introduce that into these environments easily? And that's through the concept of PBR, right? And it's the least talked about best feature I've ever seen on ACI. So if you're not that familiar with it, try to get familiar, or try to get your partner to get you familiar with, or bring us in and we will help you get familiar with it, because it's an excellent way to be able to introduce next gen features to segments that you need to introduce them to. Like in this example, I have just one EPG, right, SQL, but I could put all my databases, EPGs in this application profile and have the contract model for them. But in this contract model, I'm just leveraging BZany in this case, where I have a contract here. This could literally be, allow all traffic. Therefore, all traffic will be allowed through ACI and redirected to the firewall. Or I could get port protocol specific in contracts and redirect that to a firewall. In this case, I'm just allowing everything because I want to see all traffic. I want the firewall enforce and implement and have full visibility of everything permitted and denied between anything in the data center and the SQL segment that I'm doing. So by default, therefore, everything's segmented. This group is not part of the preferred group like we talked about. So it's a whitelist model. It can't talk to anything except what you see right here in this picture. But what it can talk to is everything, but there's a firewall in between. So for you networkers out there that don't want to do security, but just want to, be the mailman, this is a fantastic model. And it introduces segmentation much easier than having to redesign networks or have firewalls be gateways or anything like that, because what you'll see here is, there might be other services that you want, which I'll get into the shared service example, to have access into these segments too, into these secure segments. On this front, the one that always comes up too is, well, I have this secure segment. Now it needs to still talk out to the internet to do patch management, to whatever have you, right? It could be whatever you want. It's a very similar thing. I have a contract here. It's a unique contract to this app to this app profile, as well as just even to this EPG in this case, where it's a similar thing of what I'm doing here, right? I am allowing a contract, allowing everything, but I'm redirecting it to a firewall. And because of the nature of how I have this, I have everything open. And so anything coming in will be redirected to the firewall. Anything going out will be redirected to the firewall. So it kind of gets you that simplistic, let's get the databases off to the side, let's get them secured without using, all the different application workload protection vendors out there. A simple thing, I'm using my normal tool sets of firewalls and network policy to get the traffic there. This is definitely one use case, that we've seen be picking up. It's the same with, what I talked about, like backup applications and backup networks, where these are things that are, high risk areas for all enterprises and should be high risk areas, and there should be a lot of visibility into and out of those segments. But the problem too with these types of networks is the amount of throughput and the amount of traffic. I'm sure a lot of you out there know the bottlenecks that firewalls can be to back up traffic and trying to redesign different solutions. So a firewall is not in the way. It could even be a multi-NIC solution on servers or whatnot. I've seen a lot of different things. In this case, these could be multiple backup applications, right? In this case, I'm just saying I have an endpoint group and I'm using Cohesity as my backup solution. And I want Cohesity to be able to talk to everything within the segment that it's in. And I want to basically build a contract allowing that communication. This contract would typically have port and protocol specific of how you want that communication to go, but it's basically that, right? The Cohesity can talk into any of these segments and vice versa, but north and south into my backup networks, I'm putting security there. And I'm putting security there in the form of PBR. And the one thing with policy-based redirection, like you've seen, like I'll go to this contract, right? I am not setting up a new policy-based redirect for every single contract or every single group-to-group communication that I want to secure. I have the same one. I'm using a one-arm firewall, and I'm not worrying about routing on that one firewall. I'm using a service BD that it's on. ACI is going to do the work of redirecting the traffic to the firewall for me. And so if I look at, this Cohesity layer 3 out, I have two subjects. One that says no PBR, and I'm just specifying ARP and ICMP traffic to go through via just ACI policy. It's going to be allowed through. And then I have one called PBR. And in this case, I'm only allowing HTTPS to talk out to the internet. But not only am I allowing that, I'm also inserting that service graph right here. So this is inserting it to an HA pair of firewalls. I could also do, load balancing to clusters of firewalls and different crazy things like that. Most common, we see it deployed in HA pair of firewalls, physical or virtual, that it can be. So it's super easy to implement and redirect traffic to firewalls with policy-based redirection. It's the same thing if I come back and I look at that. If I just look at the SQL redirect I have, if I look at that PBR, it's the same firewall I'm redirecting to. So you could still have a centralized kind of firewall, data center firewall model, and prescriptively, say what traffic do I want deep packet inspection on, what traffic do I not need it on, and can use ACI security to allow access in and out. So backup networks is definitely another one of them. The other one that we'll get into some other features that Julian talked about, because really kind of what those two just shown are more like VZNE concepts, as well as concepts where I'm using policy-based redirect. And you're going to see that's kind of a common thing with with the way that Julian and I work is a lot of times we are going to use policy-based redirect because oftentimes when you're talking to security groups, that's needed, and that's needed for those high-risk segments. They need deeper packet inspection on the traffic going in and out of them. ACI does not do that, but it does deliver an easy way to get that traffic to and from there and keep it symmetric and do the hard things that typically we've had to, to build networks to be able to do that with. And that's even goes for multi-site. That's another rant, but we won't go there today. In this case, I want to just show kind of another thing that comes up is like, let's start setting up some shared services. And we want to also secure shared services and no kind of external in. I want some visibility there. But within the data center, I just want to secure the service and offer the service to everything. And so as an example, in this app profile, I have shared services, I have AD, DNS, NTP, a security scanner. So I have these 4 EPGs essentially in it. And those guys are basically providing a contract for their particular service. That contract is then just consumed on the VRF. And a security scanner, I'm just doing the default, common default filter set, and therefore it can scan everything. So I'm giving access to the security scanner to scan everything. I'm providing the service from all these groups to everything on what I already know what they need to provide. If at any given point I wanted to be able to insert a firewall here, if I needed to, I could literally just go to this contract and do what I just showed you, is on a subject, put the traffic I want to redirect, point it to that firewall that I already have defined, and I'm redirecting traffic there. When we look at policy inheritance, which Julian talked about, and I would say a lot of customers that I've talked to that have started implementing ACI, which again, it's probably 10 to 20% of the bunch out there, and hopefully more and more will start, they've used contract inheritance in some form or another. It doesn't have to be shared services. I've seen it used where, as a large Kubernetes shop where they had basically set up, like, here's every time we stand up Kubernetes clusters, we want to give them this access, right? So they set up one application profile, defined how they wanted to give things access, set up a master EPG, and then every time they stand up a Kubernetes cluster, it's in a new app profile, new EPG, but its contract master is the same. So all of the Kubernetes clusters have the same access to what they need to have the same access to. If I need to change any of them, I can go to that one spot, the app profile that has the master kind of template that I want and manipulate it there. And then it's as easy as, like in this example, you see NTP, AD, DNS. I'm still needing them to talk outbound, but I want to be able to have visibility on that traffic. And so in this case, you see they're pointing over here to this guy. It's not really a part of this particular app profile. This is showing contract inheritance. And so if I look at the app profile that is coming from, the contract inheritance, I only have one EPG created in that app profile called layer 3 out PBR core. And this is the EPG that I have defined there. And with the contract structure, I have one contract saying layer 3 out PBR core, and he is consuming that from this EPG. So basically traffic is initiating outbound out to the internet, right? It's initiated outbound to the internet coming into the layer 3 core. This window here shows you kind of like the directionality of this is kind of its child endpoint groups, and those can be spread across multiple application profiles within this stack to be able to show that. And so as an example, if I go, the security scanner in my app profile here of shared services was not a part of that that master. So it didn't have outbound connectivity. Maybe it doesn't need outbound connectivity, but if I wanted to give it outbound connectivity, I can find the app profile, I can find the endpoint group, and I can update it. And by updating that, and I go back into my topology, now I just gave that EPG of the security scanner outbound access, but I'm redirecting into a firewall. And so just another example of like showing contract inheritance and how it can be used anytime, like as an example of this one, right? I could have this EPG be consumed by any EPG that I wanted to like secure outbound internet connectivity and redirect it to a firewall, right? By just associating it to this this EPG. So a pretty cool, powerful feature. If I needed to change anything and I wanted to do the one-to-many and change it to many application profiles, I would really need to just go up to this contract inheritance and change it here on this, within this topology structure, within this EPG, like of what it, the contracts that it is consuming or providing. And I can do that. The last one is talking through ESGs a little bit, and this is kind of getting a little more sophisticated, right, with the policy structure. And this is kind of where the moneymaker apps of like either it's running the business or it's the data lake behind the business sort of thing. This one we're just showing it's running the business, and this is showing the ESG concept within ACI. And so if I look under the app profile, it has no application EPGs. I'm just setting up endpoint security groups. Those endpoint security groups in this app profile are just Moneymaker database, Moneymaker web. And so if I look at those, there's two things you do. You have selectors and you have contracts with these ESGs. The selectors, right now, what Julian mentioned is subnet, it's down to the host route is what's available to be able to pull in endpoints into these ESGs. Coming in a later release in 5.2 is a selector will be like an EPG, like a normal application EPG. I could select that and bring it down into an ESG construct, and then be able to write a security policy. And so now I don't have to, do stupid human tricks and different when I have like for like nodes that are split across BDs, I can start to have a common policy set without having to re-architect the way I map in EPGs to things. I think it's gonna be very powerful in a thing that has been asked for a very, very long time. My mouse is
really quick, man. Really quick, just one thing to add there. I mean, in this example, we showed the selectors were /32s, but this is the longest prefix match, right? So it could be, and I think the Moneymaker web ESG has the /24 defined instead, but just for the sake of argument here, just to make sure it's clear, it's not like you have to go in here and define a /32 for every single endpoint that you want to join. This is the longest prefix match, so I can do /24s and so forth as well. And to your point, Tony, that's what is possible today. This is a 5.1 release. With 5.2, then we'll get those additional attributes that we'll be able to use to map endpoints into ESGs.
Yep. So, I mean, basically in this app profile, I'm using the ESG concept, and I'm using, the normal kind of what you guys have seen throughout ACI's ages is like, external to web the database, or there could be an app in there or whatnot. Coincidentally too, like policy-based redirect, I could do multiple service chaining with that, and we're not showing it here, but it's interesting, right? Where I could have it come in, go to load balancer, and then go to firewall after that, or go to a WAF, go to a firewall, blah, blah, blah. Really powerful capabilities that you have in service chaining. And so in this example that I have layer 3 out connectivity, and it basically being the consumer of like my web. And so this is typical application traffic of what I'm going to allow here, but I am going to put a firewall between, my external perimeter based and my layer 3 out and ACI. Now this is kind of the decision that some customers are having now that are starting to implement this in ACI is, do I need to have deep packet inspection here, or is it good enough just to do out on the perimeter? And to each is his own. It might, in certain cases, be advisable to have that sort of feature set within the data center because of all the other networks connecting, and not just kind of on the perimeter set of your network. So security is best applied closest to the host, right? And that would kind of lead us to that, but risk reward type factor there. So that's just showing that, right? And again, all of these redirects that you see here, it's the same thing that I used in all of the other things. And so when I go to the moneymaker stuff, like this is the moneymaker application profile. I have two subjects. One, I'm not doing any PBR to. I'm just allowing ARP and ICMP. And the other one, on the external to web, I am filtering it down to HTTPS. And so ACI is kind of acting as a traffic cop and saying you're only going to allow HTTPS because that's all that should be allowed to serve up this application to the known world. And so it's allowing that. But then, as you see here, the service graph applied is that same service graph, and it's the same thing. Web to database. Excuse me. Topology on that guy. If I just look at this is allowing kind of specific things. This could be obviously open to everything, and it's still only allowing everything open, and I'm sending everything to the firewall. And so it just depends on what, do you want ACI to limit the amount of noise the firewall is getting it, or do you not want to be anywhere in the middle of the packets, aside from getting them to a firewall and away from the firewall? That's kind of a key thing to think about within this concept. But on these guys, it's just showing contract inheritance does work as well. So if I look at one of those guys and I look at the EPG, I can assign it a contract master. Its contract master is coming from corp and inherit. And so I have an app profile called corp. I have an endpoint group here called inherit. And so if I look at this application profile, this is basically the inherit ESG. And I'm doing two things with that, right? I'm allowing management traffic, and so on the management traffic side, it's going to consume the EPG, and the EPG is going to provide it coming in to the environment. And so that's what we see here. It's providing it, and then the consumer is actually the layer 3 out, and I'm allowing management traffic. I'm limiting what traffic I want to allow in, but I'm also redirecting that to a firewall. And then the same thing here from a layer 3 out perspective. What am I going to allow these application EPGs to talk out on? I'm only allowing them to talk out on HTTP and HTTPS, and I'm putting a firewall there. And so I have this kind of this inheritance. We should rename it, right? Corp is kind of not descriptive enough. It could be kind of application contract inheritance or something like that. But you guys get what it's doing. It's basically these guys are connected to here, and therefore the endpoints in these ESGs have connectivity to these services, right? Management services can come in and talk into the ESG, as well as outbound of these guys. I'm allowing outbound traffic to the internet, but I'm redirecting both to a firewall. So that was kind of a lot. I'm going to pause. I don't have much more than that, Davis. I went really fast there. I don't know if there's any questions or not, but just some typical examples of what we're seeing out there. And the network centric secure database, the backup networks, things like that. I'd be curious, there's lots of different ways that users have done that throughout the ages, but these are some pretty simple ways to do that. And we've worked with customers doing multi-tenancy and setting up shared service VRFs and doing that into other tenants within ACI, and so that's all possible, and hopefully going to get better as ESGs get better too, as far as the route making goes.
Yeah, I really like your examples, and I think you make a good point with PBR. I think we see PBR as this feature that we have to have some special use case for, but most of our firewall redirect is going to be traditional routing to the firewall, or sort of traditional ways of putting it in path. But I like this idea let's just use PBR to put it in path. It works very reliably and consistently, and I can turn it on and off. I can be very selective, and by just saying that that's the way I'm going to get to the firewall for all this east-west traffic, it really it's kind of back to that keep it simple idea of there's a simple way to insert it. I can and I can do that consistently, and I can make a consistent policy in my fabric that way.
Yeah.
It brings me back to another point, and I've really kind of been thinking about this one a lot this week, and it's really as I've been talking to people more and more about the SDA integration with Campus, Campus with ACI. One of the things that, or really the thing that is accomplished with that integration, is the communication of security groups between zones, right? So ACI is defining a security group, whether it's an endpoint security group or an endpoint group. It is saying these are things that should have like security policy. Meanwhile, there's the SGT on the campus side, whatever. Even if you're not using ACI to enforce the security policy, if you can use it to make that definition and then communicate that definition outbound. So whether it's with an app integration with FTD to create network objects on an FTD based on an endpoint group in ACI, or it's the ICE integration with SDA, where I can create that SGT on the campus side that maps to a security model in the data center, I still have the one place in the data center where I define that network object. And I think that provides a lot of value in defining the security policy for your organization.
Yeah, absolutely. And I think to the one point, we've worked with you guys and whatnot too in the labs, as far as like the FTD integration. And it's really important, I think, when you get more into automation, rather than having to automate, access control policies on firewalls, to do it based off of identity groups, and have it already be done. And whether or not there's an endpoint there or not is up to the guys that are automating the endpoints into those groups, right? My security policy is set. You guys go ahead and build whatever you want on top of this, and these are the areas that you can build into, and so it makes for a more streamlined policy, in my opinion.
I like it.
Anybody have any questions out there? We both went pretty fast through this. Good, bad, or indifferent, and like again, everyone is different, and there's a lot of varying levels out there of how people have implemented ACI. But this is just food for thought. We're trying to get out there for people to start using more and limiting user access into the data center when it's not needed, right? And like these simple things of like my backup application concept or my secure database topology. I mean, it's not really that difficult. This guy's just not a part of the preferred group, but that's all there is. And so like it can't talk out of the layer 3, because of that. And so I have to have a contract set up saying what it can talk out, and I can either secure that just with ACI, or if I want deep packet, I throw a firewall in there.
Very cool.
Cool. Chris, you've been very quiet. Is Chris still on the call?
I think he just dropped, actually.
Dang it. I was going to say, it's the quietest I've ever heard him on call.
I thought this was great. Thanks, guys. I think the examples are probably the most useful for helping me communicate to the folks I work with.
Yep.
I really like the way Julian broke down the security model, and it's something that I think a lot of people who have established ACI in their data center, they don't understand the security model as well as they need to, maybe. And the way Julian broke it down was fantastic to really show you the different ways you can deploy security policy and the different use cases for that. It's fantastic.
And that was even handcuffed, right? It was actually a lot better than that.
I was going to say it goes much better if I can actually present it the way I intend. So my next step is to figure out how to do my iPad with WebEx Teams when I don't have WebEx that way. So, yep.
Well, appreciate the time. And if anybody has any questions or anything, we're here to help now. So I don't know, Davis, if you want to share our contact or whatnot,
Sure.
we're out there now and happy to help.
Absolutely. All right. Well, thanks very much, guys. And yeah, absolutely. Everybody, feel free to reach out. How do you, the slide decks, if you want, well, we'll have the recording shared. If you feel like sharing your slide decks, we'll be happy to share that in the space as well. And then as I mentioned at the beginning of the call, Tony and Julian will be back next month to talk to us about some automation efforts. So that'll be kind of some cool stuff to talk to. And and that's really all we have for this week or this month. Anybody with some last thoughts or shares before we close up the meeting? Open it up. All right, I'll take silence as golden. Well, thanks everyone for joining us, and we'll see you guys in August, or well, maybe next month, definitely in August. All right, take care, everyone.
Thanks, Davis.
Thank you.